Hello student, welcome to lesson 3 in the first module of this course in trigonometry. In this module, we are studying angles and trigonometric functions. Now, we have started with study of angles. We looked at, in the first lesson, we looked at the definition of angle and the degree measure. You might recall, as we go through this, and then we talked about the quadrants and the positive and negative angle and all of that. Then in the second lesson we studied the radian measure, and the radian measure was now related to the circle, unit circle, and then we had that angle at the center associated with the arc, right? Arc length of the circle and the area of the sector. Okay, and we had the conversion between degree and radians. We discussed all of that. Now we are building on that, right? We talked about the length of the arc of the curve of the circle. Now we are trying to connect some more linear things to circular things. So here in this lesson we will talk about angular and linear velocity. Now we are familiar with the concept of linear velocity. It is the speed on a straight line. Now what is the connection of that with the speed on a circular path? When something is moving in a circle, what is the relation? Okay, turns out as you can expect, when you are moving in a circle, there are two things happening, right? You can look at the linear in the sense you can look at the actual speed of the rate in which you are covering the distance, but you can also talk about how fast are you rotating, like in how much time are you making one full circle, right? That will be the angular speed. So we are going to study the connection between these two. Okay, so let us begin here. If a point is in motion on a circle through an angle alpha in time t. So here, I have not left many blanks here. So you can highlight or circle when I do underline or highlight any component here, so you will know what is being emphasized and stay active when you're taking the notes. Then the angular velocity. Okay. The angular velocity of that object is given by, it is covering angle alpha in time t, right? So alpha divided by t, radians per unit time. Maybe I should write that alpha a little better. Alpha over t, radians per unit time. Okay, that is basically the definition of what an angular velocity is. We are going to connect that with the linear velocity that's going to be on the right side of the page. Before that, we are going to take a small detour and talk about some of these unit conversions, okay? Because now we are going to be doing a lot of this, it is important that we are familiar with some of these units. One revolution, now the word, okay? One unit that you will hear in angular velocity is the word revolution. And one revolution is one full circle, okay? And then you can understand that should be 2 pi radians, right? Which means 1 radian would be 1 over 2 pi revolutions, okay? And then there are some other units which are commonly used. I just wanted to mention here, so you will, if you can remember them out of your head, it is useful. 1 mile is 5,280 feet. So 1 feet would be 1 over 5,280 miles. That is length, unit of length conversion. Similarly, sometimes you have to convert from miles to kilometers. Okay. which is 1.60934 if you want to use a precise value. Approximate value you can use 1.61. That is 1 mile. Okay, 1.61 kilometers. And if you want to convert from miles to meters, then you can multiply by another 1000, right? So 1609.34 meters. And sometimes you just take 1609, for approximation, but this is the exact value. And because we are talking about this, speed here, sometimes we'll be talking about in terms of some uncommon units of time that we talk normally about seconds, hours, minutes, but there are also months and years and days, right? There you have to be a little bit careful, because if you go to if you count the number of days in a month, it depends on the month, right? What we do is we standardize it, and normally we just say 30 days. If you don't know the month, it is a convention to consider it 30 days. Okay, which means one day would be 1/30th of a month. Okay, all right. Those were some unit conversions. Let us do some immediate practice. Convert this quantity. It is some kind of angular velocity. You can understand it's radians per minutes, right? So it is some angular velocity. You change its unit in terms of revolutions per second. So if it makes 148.3 radians in a minute, that is not very intuitive to me, right? If someone tells me how fast is this spinning, it is making 148.3 radians in 1 minute. Okay, that's not very helpful, right? How many revolutions does it make in 1 second? That will make more sense to me. So let us do that conversion. Radians. So the way we do this is like this, okay? Now I was talking about the reason why we might want to convert earlier. Now I'm going to get into the process of how exactly to do this correctly. Okay. What you do is you write that as a fraction. Okay, 148.3 radians per means division, right? Divided by 1 minute. That helps you to do this, get this correct. Okay. Now you want to convert radians to revolutions. You divide by 2 pi. Remember, 1 radian is 1 over 2 pi revolutions. Okay. So divided by 2 pi. Divided by per second. So you need to convert minutes to seconds. 1 minute is 60 seconds. Okay. Then you simplify that, and that's your answer. Let me move it up a little bit. And that you do on a calculator. Okay, 148.3 divided by 2 pi. I'll show you how you do that in a calculator. Use parentheses, divided by 2. Yeah, both pi and 2 have to divide, right? So you can do divided by 2 divided by pi. I don't know if it was for your video or somebody else's. I had made a mistake the other day. So you are dividing by 2 pi. So divide by 2, divide by pi. Don't do 2 times pi. Okay. If you want to do 2 times pi, then put the 2 times pi in parentheses in calculator. These things are important. So 148.3 divided by 2 pi divided by 60. Right? This whole thing in parentheses divided by 60. That's your answer. Okay. So what do I get? 0.39. I'm just going to round off 39. I'm going to leave it at 2 decimals. Okay. Approximately now I'll say 0.39 revolutions per second. Okay. Next, convert. Now that is more like a good idea to me, that it makes a little less than half of a revolution in a second. No, convert 150 per second to miles per hour. Now you can go ahead and give it a try and then check with me. This is 150 feet over 1 second, which then you would write as 150 divided by, because you are converting to miles, 5280 miles over hours, right? 1 second is 1 hour 60 minutes times another 60, then that will become hours. Okay, so basically every unit in the numerator and denominator, do the conversion. Your answer will be taken care. Okay, and here a little bit of calculation techniques will help you. The 60 times 60 will flip over and get multiplied. Okay, so 150 times 60 times 60 divided by 5280 miles per hour. That will be your answer. Okay, and maybe I just want to make this a little bit smaller in front so you're not mistaken. Okay, and then I'll zoom out for you. Okay, now put that in a calculator. 150 times 60 times 60 divided by 5280. 102.2727. Okay, so approximately 102.27 miles per hour. Okay, a windmill for generating electricity has a blade that is 300 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second for the tip of the blade given the monthly number. See, now here's the thing. If you are going to analyze, the how at what speed the windmill is spinning, it's going to vary, depending on the wind and day and night. So what you do is, instead of that, you take an average for over a month. Okay. So suppose they counted for a month and they found that it makes 999,000 revolutions in a month. Now convert that to radians per second. Okay. So this is 99000 revolutions per month. Okay. Convert to radians per second. Now one revolution, 39 is 2 pi radians, and 1 month is 30 days. Okay. Each day has 24 hours. Each hour has 60 minutes. Each minute has 60 seconds. That is 30 days, 24 hours, 60 minutes, 60 seconds. Okay, radians per second now. And put that in the calculator. Okay, I'm just going to do that and put it. Turns out it is approximately 2.4 to 3 angle, okay, radians per second. Check with your calculator. Okay. Okay. Now with that unit conversion, now we can talk about some angular velocities. Angular versus linear. Now again, there is a paragraph here without any blanks, so I'm going to highlight, underline, you circle them. Okay. If a point is in motion on a circle with angular velocity alpha radians per unit time. Okay. So the okay, I should not highlight radians, alpha. Alpha is the angular velocity. Okay. So in like actually I should explain this with a diagram. So what's going to happen is if you are on that circle in a given time, in 1 second, you are going to make that angle alpha rotation. Okay, this will take alpha. Okay. So in 1 minute, you rotate by that angle alpha. That is the in 1 second, you rotate by that angle alpha. That is when you say your angular velocity is alpha radians per unit time. Then what is the linear? Now the thing is, linear is how much actual distance it covered, right? Then if you pay attention here, you'll realize this is the actual distance covered, which is the arc length S. So the actual, so your linear velocity will be given by the distance covered divided by time. Now we know this arc length formula, S is alpha r, so alpha r over t. Then you isolate that r, we are left with alpha over t, which is the definition of your angular velocity. Okay, hence r omega. So what do you get? V equals r omega as your equation. That is the linear velocity, which is v, is radius times the angular velocity. Okay, so the connection between linear and angular is the linear velocity is radius times angular. That's it. That's the concept we wanted, and we can immediately do some problems. A common speed for an electric motor is 3450 revolutions per minute. Okay, like maybe when you buy motor, it will have specifications, right? The revolution is the speed, angular speed is that. Saw blades of various diameters can be attached to such a motor. Okay, like the lawnmower we have, let's say it has an electric motor that has that speed, and you can attach blades to it. Determine the linear velocity, distance traveled per unit time in miles per hour for a point on the edge of a blade with diameter 12 inches. Okay, now the motor is rotating at that speed and you're attaching a blade to it. So the blade also will rotate at that speed, which is the angular speed given here. Now, if the blade is 12 inches long, or I don't know, blade might be like whatever inches long, the point on the blade is at a diameter 12 inch. Okay. Edge of a blade with a diameter 12 inches. Then what is the speed? Linear speed. So to understand this, let us first draw a circle. Okay. In that, diameter of this circle is 12 inches. So I'm understanding that the radius is 6. This is, you have to be careful. Okay. Edge of a blade with a diameter of 12 inches. I just want to make sure that we are interpreting that concept correctly. Saw blades of different diameters can be attached. Okay. Saw blades are discs. Yeah. Okay. So the diameter is 12 inches. That means the radius is 6 inches. And that blade is attached to this motor. And the motor is spinning 3450. Okay. So R, basically the point is R is 6 inches. And omega, the angular velocity is 3450 revolutions per minute. Okay. And what you need to find? Find the speed in miles per hour. There are a lot of unit conversions going to be done here. Okay. You need to find the linear velocity, but in miles per hour. Okay. So let's do it one by one. First of all, the first step is linear velocity v is r omega. Okay. When that omega is measured in radians per unit time. Sorry, when the angular velocity alpha is given in radians per unit time. Here, the omega is given in revolutions per minute. So you need to convert to radians per minute first. Okay. So 6 inches times 3450 revolutions, right? So you multiply by 2 pi times 2 pi. Then it has become radians per unit time. So that is per minute. Okay. No, not radians. Now we're talking about linear. That is inches. Inches per minute. Okay. And that is the linear velocity. And that we need to now convert to miles per hour. Okay, so let me do it first. 6 times 3450 times 2 pi. And give me a second. That many inches divided by 1 minute. Now you have to convert to miles per hour. So 6 times 3450 times 2 pi divided by inches to feet. You divide by 12, that goes to feet. And that you divide further, which is basically multiplying here in parentheses. Remember, 1 feet is 1 over 5280 miles. Okay, we talked about that unit conversion earlier. So divided by 12, divided by 5280, I'm putting them together. So 12 times 5280 in the denominator. Okay, and once again, I'll explain what is happening here. 1 inch is 1 over 12 feet, and 1 feet is 1 over 5280 miles, right? So 1 over 12 times 5280 miles. That is what is happening in the numerator. And what about the denominator? Divided by 1 minute, and we need to convert it to hours. And that is 1 over 60 hours. Okay. I'm going to erase this to avoid confusion. And I'm going to decrease the font. Now we can write the solution here. Okay. Once again, I'll pause the video and get to Okay, so I did that calculation of record. Um, Make sure that 60 in the denominator, you flip it and multiply with the numerator when you do the calculation. Okay, 123.16 miles per hour is what you should get. Moving on. What is the angular velocity in radians per second and linear velocity in inches per minute for a point on the edge of a 12-inch diameter record spinning at that speed? The same, very similar question in different wordings, different context, but the same idea. Okay, please go ahead and do it and then check your work with me. Okay. So once again, radius is 6 inch and the angular speed spinning. Okay, this given here is your angular velocity. That's alpha. This is 33 whole number 1/3. That is 100 divided by 3. Convert it to proper fraction. Okay, revolutions per minute. And what do we want? First, we want it in radians per second. Okay, angular velocity in radians per second. So 100 divided by 3, and one revolution is 2 pi radians per 1 minute is 60 seconds. Okay, now do that calculation. It is times multiplication here. 5 and 3 here. So I don't think anything else multiplies. That will be 10 pi over 9 radians per second. Okay, that's the angular velocity in radians per second. Linear velocity in inches per minute. Okay, now the linear velocity V is alpha r alpha, the way we have been writing. And in this case, it will be 6 times 10 pi over 9 r alpha inches per second. Okay, inches second. That's where it is coming from. Okay. And what do we need to do? Convert it to inches per minute. Okay. And pay attention here carefully. That will be, you cancel the 6 and 9 2 times and 3 times. So 20 pi over 3 is the value. Inches is inches. That second you have to convert to minutes, right? 1 over 60 minutes. So in your calculations, that 60 should go up now. 60 times 2 pi divided by 3. And I want to make sure that it stays on your screen. So I'm going to move it up. 3 will cancel with 60, so you get 40 pi. Okay, 40 pi inches per minute. Okay, and if you want like a decimal value, you would plug in the value of pi, otherwise you can leave it at that. Okay. Another problem. What is the linear velocity in miles per hour of the tip of a lawnmower blade spinning at that for a lawnmower that cuts a 20 inch wide path? 10 inch wide path. 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 10 inch They sound similar, okay, but like in real world, the context is slightly different, so we need to interpret accordingly. That's the practice we are doing. Now, what is happening here? A lawnmower, when you move it on your lawn, like you travel in a straight line, it makes this 20-inch wide path. So the question is, the lawnmower has this blade, right, which is circular. What is the radius? And the answer is again the same. The radius is half of that width of the path, right? Because the blade is, when it rotates and then you move forward, the diameter of that blade is what is making this path. You understand? The blade is here. This is the blade of a lawnmower. And when it is spinning, that is the blade spinning and making the 20-inch path. So the radius of that blade is 10 inch. Now the question is tip of that blade. Okay, so we're talking about the linear velocity now. If the tip of the blade is somewhere here, so how fast it is moving, linear velocity, right? 2800 revolutions per minute. You need to convert it to miles per hour. Okay. Now we are familiar with this technique. Alpha given here is 2800 revolutions per minute. So your linear velocity V will be R alpha. So that will be 10 times 2800, 28,000 revolutions. No, we need to multiply that to times 2 pi. Okay, inches per minute. So let me do it this way. I'll move this a little to the right. Okay. Inches per minute. Why did I multiply by 2 pi? This is revolution. Okay, I need to convert it to radians. When you convert to radians, then the formula. Okay, V equals R alpha works only if it is in radians. That is very important. Okay, and so the unit of length here is inches. So the 28 alpha R 2800 times 10, 28,000 times 2 pi to convert from revolutions to radians, inches per minute, right? That is the velocity. We want that in miles per hour. So 2800 times 2 pi inches divided by 12. So it is in feet divided by another 5280. So it is in miles now. Okay, that is numerator. And denominator, you have 1 minute. You need to convert to hours. So what do? You replace that with 1 over 60 hours. 1 minute is 1 over 60 hours. Okay. So again, do this calculation on a calculator. Remember, this 60 will go up and multiply with the 28,000 there. Okay, and both 12 and 5280 are in the denominator. Use a calculator. Okay, so that's the expression I typed in the calculator. You can check here, and 166.59 is what we seem to be getting. Okay, 166.599. So I'm going to go with 6. Right, 166.6 miles per hour. Okay, one last question. If a car runs over a nail at 55 miles per hour, okay, so the car is moving on the road at 55 miles per hour and it runs over a nail. And the nail is lodged in the tire tread 30 inches from the center of the wheel. Okay, say this is the wheel of the car, 13 inches from the center. The nail is lodged here. Okay, and what is the angular velocity of the nail in radians per hour? Okay, so this nail, in 1 hour, how many radians will it make? So this is converting from linear to angular. All right. So V is R alpha, which means the angular velocity alpha can be written as linear divided by radius. Now the linear here is 55 miles per hour divided by the radius is 13 inches. Okay. So you need to make the units consistent, first of all. And what do we need our answers in? Radians per hour. Okay, so the unit of time should remain hours. The radians comes automatically. Okay? You don't see the radians unit, when writing. You can write that at the end. Important thing is the time should be in hours, and that is in hours already. So we're good there. What do we need to do then? We need to make sure that the length is also of the same unit, right? Then you can cancel correctly. So I will convert miles to inches. That is easy. 55 times 12. No, sorry. Miles to feet first. 5280. That converts miles to feet times 12. That converts feet to inches. Now that is in inches divided by 13 inches. Both are in inches now. So you can cancel that and say your answer now is radians per hour. Okay, that's how it works. Okay, here the radius is 13, by the way. You would have already noticed that. Again, put that in a calculator. 55 times 5280 times 12 divided by 13. Okay, 55 times 5280 times 12 divided by 13. And that is 268061.53. 268061.53 radians per hour. Okay. And with that, we are done with the third lesson in this chapter. Thank you. I'll see you in the next video.